Hello class and welcome to section 7.3, square root functions and inequalities. We're going to go ahead and graph square root functions and inequalities today. But before we do that, we're going to go ahead and consider the function f of x is equal to x squared. Okay. Our directions here tell me to find f inverse of x. Well, we found f inverse of x in our last notes. So what I'm going to do is I'm just going to rewrite. We have f of x is equal to x squared. There's two ways to think about it. You can switch the x and the f of x, or you can just go ahead and solve for x. So I'm going to start out by just solving for x. If I want to get x by itself, I would take the square root on both sides. Okay, so the square and the square root will cancel, so I have the square root of f of x is equal to x. Now in order to get the inverse, I'm just going to switch the two. So I would have and write f inverse. So f inverse of x is equal to, I'm going to put in an x for the spot, the square root of x. So here is my inverse. So if you take note, my square root of x is the inverse of x squared. Okay, so we're going to go ahead and graph both of these, but notice this is my square root function. And that's what we're graphing today. So let's start out with the function that we know, f of x is equal to x squared. Well, we know that that's a parabola, so let's go ahead and graph it. If I plug in 0, 0 squared is 0, so I have the order pair 0, 0. If I plug in 1, 1 squared is 1. If I plug in negative 1, I will get out 1 because negative 1 squared is 1. If I plug in 2, 2 squared is 4. Same thing if I plug in negative 2. Negative 2 squared is 4 because negative 2 times negative 2 is 4. If I go ahead and graph this, here is my f of x. This is my parabola. Now let's go ahead and graph our square root function. Okay, if I plug in 0, 0 squared is, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Let's pick our next perfect square. Let's plug in 4. The square root of 4 is 2, so plug in 4 and I get out 2. If I take the square root of 9, that'd be over here, I get 3. So here is my square root function. So this is my f inverse of x. All right, so here's my inverse. We talked about inverses yesterday, so one thing to notice is that if you ignore the left-hand side of my parabola, you can see that these two are symmetric across my line y equals x. So being symmetric means that if I flip it across that line, they would match up. Okay. Why do I have to ignore the left-hand side of my parabola? Well, it's negative 1. Can I take the square root of a negative? Okay, well, I can, but it doesn't give me a real answer. It gives me an imaginary number. So we are not worried about the negative values. Okay. Biggest thing that I want you to take note from here is that x squared and the square root of x are inverses of each other. They undo each other. The other thing is that look at how my square root function looks like. Okay, I start at one point and I go to the right. Okay, it will always take this shape when I graph a square root function. So if you graph a square root function and it doesn't look like what I have in green here, that means you've made a mistake. All right, so let's go ahead and look at example 2. Okay, we want to graph y equals x plus 2. We want to state the domain, the range, and the x and the y intercepts. Okay, biggest thing is, let's start with domain. Domain is my x values, and it's by taking what is underneath your square root sign and saying it has to be greater than or equal to 0. Okay, the reason is if what's underneath here has to be greater than or equal to 0 is because you cannot take the square root of a negative. Okay, so my domain would be that x plus 2 has to be greater than or equal to 0. And then you solve that. I would subtract 2 to the other side, so x has to be greater than or equal to negative 2. This is my domain. My range then comes from what's after the square root sign. If I rewrite this, after my square root sign, it's really plus 0. So my range is my y value, so it's y is greater than or equal to 0. Okay. I always recommend that when you do your table, because I'm not going to give you a table on your test or your quiz and possibly even on your homework, is you always start with your domain. Okay. My domain is negative 2. So really my table should be starting at negative 2. And when I plug in negative 2, you'll get out your range, which is 0. So let's just double check that. If I plug in negative 2 plus 2 is 0. The square root of 0 is 0. 0 plus 0 is 0. There it is. Okay, why do I recommend not plugging in negative 3? Well, let's try it. Negative 3 plus 2, that's negative 1. The square root of negative 1, if you try it on your calculator, it's going to tell you it's an error because it is undefined. Okay, so always use your domain and range to tell you where to start your table. So use that to start your table of values, okay? Then the next thing we need to go ahead and do is find your x and your y intercepts. Okay, well, you always find your x-intercept by letting y equal 0. So I'm going to plug 0 in for y here. So I have 0 is equal to the square root of x plus 2. Okay, to solve this, to get rid of my square root sign, I would square both sides. So I have 0 is equal to x plus 2, and if I solve this, subtract 2, I would have x is equal to negative 2. There is my x-intercept. My y-intercept then. To find your x-intercept, you let y equal 0. To find my y-intercept, I let x equal 0. So I have y is equal to the square root of 0 plus 2. 0 plus 2 is just 2, so I'm just going to leave it as the square root of 2. So my y-intercept is the square root of 2. Okay, now we're going to go ahead and finish graphing it. So I'm just going to fill in the rest of my table. So if I plug in negative 1 plus 2 is 1. The square root of 1 is 1, so it's going to be 1. If I plug in 0, it's going to be 0 plus 2, so it's the square root of 2. So I'm just going to write the square root of 2. If I type it in on my calculator, I will get that it's approximately 1.414. Now if I plug in 1 plus 2 is 3, so it's the square root of 3. And once again, I would type in the square root of 3 on my calculator, and I get 1.732. Okay, now I'm going to go ahead and graph it. So if it's undefined, there's nothing there to be graphed. So I would plot the point negative 2, 0, negative 1, 1, 0 square root of 2, so 0, 1.41. So just estimate. Then I have 1.732. Okay, this is my square root function. Notice how it makes the same shape as my function from example 1. Okay, if you have any questions on example 2, please write them down. Or if you need to take a little break, go ahead. All right, so let's go ahead and move on. So some math rules to live by. Okay, we have to keep these in mind, especially throughout this chapter. You can't divide by 0. It's the same thing as having 0 in the denominator. You can't take the square root of a negative number. You can't have negative exponents in your simplified answer. You can't have radicals in the denominator. So remember, a radical is your square root sign. Can't have those in the denominator. And you can't have fractional exponents in the denominator. So to find the domain of a square root function, I already talked about this, but the radicand has to be greater than or equal to 0. Okay, so set the radicand greater than or equal to 0 and solve for x. So here is 2 examples. We want to figure out what the domain is. So what's underneath my radical, I would say 4x plus 2 is greater than or equal to 0. So I would subtract 2. So I have 4x is greater than or equal to negative 2. Then I would go ahead, divide by 4. So x is greater than or equal to negative 2 over 4 is negative 1/2. So my domain is that x is greater than, so this is domain, is greater than or equal to negative 1/2. All right, I move on to y. Okay, it's what's underneath my square root sign. So 2x minus 3 has to be greater than or equal to 0. I'd add 3 to both sides. So I have 2x is greater than or equal to 3. And then I would go ahead, divide by 2. So x is greater than or equal to 3 over 2 or 1.5. That is also my domain for this function. X is greater than or equal to 3 over 2. Okay, so that's how you find the domain. Now let's go ahead and look at the range of a square root function. Okay, just look at the number after the radical. Okay, so the number after my radical here is c. That is my range. It's whatever is after the radical. Okay. Okay, so if there's no number after the radical, then the range is really just y is greater than or equal to 0. Okay, if there is a number, then the range is y is greater than or equal to that number. So notice it's always y is greater than or equal to. Okay, whatever it is after the radical. So if I look at the example that I had earlier, we found the domain for both of these. Okay, now I'm going to find the range. Is there anything after the radical? No, it's really plus 0. So my range is y is greater than or equal to 0. Range is really easy with my square root functions. Same thing here. Now there is a number, so it's y is greater than or equal to 4. That is my range for this problem. All right, moving on to example 3. Okay, we're going to do the same thing. We're going to graph it. We're going to find the domain, the range, the x, and the y intercepts. So I always recommend finding the domain and range first, no matter what, even if it doesn't tell you in the problem to do so. Okay, so let's find my domain. Okay, biggest thing to remember is that's whatever's underneath the square root sign. It has to be greater than or equal to 0. And this is to find your domain. So if I divide by -2, biggest thing to remember with this is, with inequalities, if you divide or multiply by a negative, your sign flips. Okay, so x is less than or equal to 0 divided by -2 is 0. So that is my domain. Now my range, remember, is just the value that's after the square root sign. So y is greater than or equal to 3. Okay, let's go ahead and find my x and my y intercept. Okay, remember you find your x-intercept by letting y equal 0. Okay, so I'm going to plug in 0 for y. So first things first, I would subtract 3, so I would have -3 is equal to the square root of -2x. Okay, one thing to take note of is, can you take the square root of anything and ever get out a negative? No, you cannot. Okay, you will never get a negative from a square root. So what this means, if you ever get a square root equal to a negative, that there is not an intercept. So there is no x-intercept. Okay, it will never touch the x-axis, that means. My y-intercept, remember that's when x is equal to 0. So y-intercept, that's when x is 0. So I have y is equal to -2 times 0 plus 3. Okay, -2 times 0 is 0. The square root of 0 is 0, so it's y is equal to 0 plus 3. So my y-intercept is 3. So it's really the order of pairs 3, 0. Sorry, excuse me, 0, 3. So we're going to go ahead and we'll plot that. So I'm going to have 0, 3. So I know for sure that's on there. Now the last thing that I do need to do is I need to make a table and graph this. Okay, I'm going to run out of room, so I'm just going to erase some of this. If you need to, you can go back. Okay, so I'm going to make a table. And remember, my table always starts out with my domain and my range. My domain is 0, and it's when my range is 3. Now I pick my table off of what I have here. Okay, it says x is less than or equal to 0. So to be less than 0, I would also plug in -1, -2, -3. Okay, this is one way to do this, and then I can plug all those values in. The other way is to use your graphing calculator. Okay, if you want to use your graphing calculator, I'm going to graph the function. So I go to y equals, and I say I'm going to graph the square root, so second square root of -2x, mark the negative, -2x, okay, plus 3. And I'm going to go ahead and I'm going to look at the table because I'm making a table here. Remember, to get to your table, we're going to go to table set, which is right above the window. So second table set. Okay, and I want to start, where do I want to start? This is saying I'm going to start my table at -3 right now. I want to start my table where x is equal to 0. So I'm going to do 0. And then this delta table, that's what we want to count by. Okay, we want to count by ones. Okay, so I'm going to start it at 0. We're going to count by ones. So to look at my table, okay, see how above graph it says table, so second table. Okay, notice at 0, it's 3. But if you go bigger, they all say error because it's undefined. You'd be taking the square root of a negative. So I just need to go up. So at -1, I would have 4.4142. That's the value I would have. At -2, I have 5. You know, and I could go through and look through these and just find the values that are nice whole integers if I wanted to. And I could graph just those. Okay, but I would recommend graphing, you know, a few points at least to cover up the entire graph. So I'm just going to go ahead and jot a few of these down. So at -1, I would have 4.412, and at -2, I have 5. And at -2, I had 5, and at 3, I have 5.4495. Okay, and that's going to get me some values. I would also look at this and say, well, how far, we're going to the left, excuse me, because we're going negatives. How far does it go to the left? This is -1, -2, -3, -4, -5, -6, -7. So maybe I just want to see, well, where is it at -7? So I go back to my calculator and figure out, well, what is it? It's 6.74. So 6.714. So I can graph these numbers. Okay, if you don't have a graphing calculator, you can do the same thing. All you'd have to do is plug all these in. So you'd have -2 times -1, which is 2. Take the square root of 2 and then add 3 onto it. Okay, so let's plot these. So I have 0, 3. I have -1, 4.412. -2, 5. -3, 5.4. -7 was 6.7. Okay, so then I would go ahead and I would ask myself, oops, that got a little messy. I would ask myself, is this the same shape that I had when I did my first one on the front, the very top of this note sheet? It is the same shape. Okay, the only difference is it's flipped around. Okay, so this one doesn't look very nice on here, but there. So it should look the same shape as what we had on the front side, something like this, but it's just flipped. Okay, so there is example 3. If you have any questions, feel free to pause the video and ask and write down any questions. Now would actually be a really great time to take a break if you need one, because we're going to get into square root inequalities next. Okay, so we're going to graph some square root inequalities. So they can be graphed the same way as a square root equation. So we're going to do the same process to graph it. The only thing that's different is when you're done, you're going to shade. And we're also going to say, should the line be solid or dashed, and that kind of thing. So things to remember is that if you have a less than or greater than sign, that requires a dotted or dashed line, whichever way you like to talk about it. I call them both. Okay, you're going to use that dotted or dashed line. So it means you're going to have a line that looks like this. Okay, if you have less than or equal to or greater than or equal to, then it's going to be a solid line. So when you graph it, to be solid, you'll look like this. Okay, so you might be dotted or dashed or solid. Okay, so that's one thing you need to remember. So example 4, we're going to go ahead and graph this one. Okay, always start out with finding your domain and range. Okay, so I notice how it doesn't tell you that, but I'm going to remind you. So we're going to find my domain. Where you take what's underneath the radical and say that has to be greater than or equal to 0. So I would add 6 to the other side, divide by 2. So x is greater than or equal to 3. Then I'm going to go ahead and find my range. Remember, that's your y values, and it's greater than or equal to what's after my radical. There's nothing there, so it's greater than or equal to 0. Now what I'm going to do is I'm going to go ahead and make a table. Okay, it says x is greater than 3, so if I plug in 3, I should get out 0, because that's what my range is. Let's check. If I plug in 3, 2 times 3 is 6. 6 minus 6 is 0. The square root of 0 is 0. That's exactly what my domain and range said. Now let's go ahead and figure out some other points on here. So we know this is like our starting point. I'm just going to graph it on here, 3, 0. Okay, so we have a little bit of room, not too terribly much. So let's just go ahead and type this in on our calculator and get the rest of our table. Otherwise, you guys can go ahead and you can just pick values greater than 3 and plug them all into your calculator if you do not have a graphing calculator. So once again, I'm going to go to y equals, I'm going to clear it out. So we're going to do the square root of 2x minus 6. Oh, I did not get the square root. Okay, and now I'm going to go ahead and hit graph. Or I could hit graph. You could check what it looks like. Okay, so I know it's going to look like that. Then I would look at my table. So in order to get my table, I remember again, it's above the window, so it's second table set. Okay, this one says starting at -8. We want to start at 3. So 3 and enter. And I want to count by ones. And then let's go ahead and look at the table. So to get to table, it's above graph. So second graph. All right, so at 3 I have 0. Notice how at 5 it's 2. So I'm going to write down the ones that have nice values. I'm going to do 5, 2, and then it says 11, 4. I don't think our graph goes all the way out to 11 though. So let's just see. We got 5, 2. So I'm going to have the ordered pair 5, 2. And maybe let's just figure out, well, what is the value at 7? Because that's the end of our graph. Okay, so at 7, what does my thing say I have? I would have 2.824. Okay, so I'm going to go ahead and graph that 7, 2.824. So almost 3. Okay, now before I do it, I look at this. It's an inequality. It says y is less than. So this is a dashed line or dotted. Okay, so dash it up or dot it. Okay, now we need to shade. Okay, so when I shade, it says y is less than. So if I shade less, it's below. Okay, so I'm going to shade below the line. One other thing to keep in mind, though, is my range is y is greater than 0. So I'm really only going to shade this piece right in here. Okay, so that is how I would graph example 4. If you have any questions on example 4, please write them down. Pause the video if you need to. Otherwise, let's keep moving on. Example 5, we're going to go ahead and graph this one. Okay, right away I see it's an inequality. Y is greater than or equal to. So this tells me it's a solid line because it's equal to. Okay, so I can draw a solid line. And same thing, let's start out with our domain. It's what's underneath the radical. And it has to be greater than or equal to 0. So to solve this one, I would multiply by 2 on both sides. So x is greater than or equal to, well, 0 times 2 is 0. So x is greater than or equal to 0. And then remember my range just comes from what's underneath my radical. So y is greater than or equal to, what's after it is 2. Okay, so let's go ahead and make our table. Now we have that x is 0 because my domain and my y is 2. Let's just check, does that work? Okay, 1/2 times 0 is 0. Square root of 0 is 0. 0 plus 2 is 2, so that does work. And it says x is greater than or equal to 2. So I would pick numbers greater than 0 to plug in there. Okay. Once again, I'm going to go ahead and do it on my graphing calculator. And if you don't, you can just pick numbers greater than 0 and plug them in. So I go to my y equals again. I'm going to clear it out and type in my new equation. So it's second square root of 1/2 x. Okay, make sure you get out of the square root, plus 2. Okay, now I'm going to go to my table. I want my table to start at 0. Oops, second table, it's above the window. Second table set. Okay, there we go. We want to start at 0, so I'm going to hit start at 0. I'm going to go by ones, and I'm going to go ahead and second table to get above the graph. So I get out 2, and then if you notice at 2, I get out 3. So I have the ordered pair 2, 3, and at 8 I have 4. Okay, I don't know if that one's going to fit on there, so let's just do 2, 3. So I'm going to have the ordered pair 2, 3. So let's just see what I have. 0, 2. Then I have the ordered pair 2, 3. How big does this go? 1, 2, 3, 4, 5, 6, 7 again. So let's see what I get, 7. When you plug in 7, you get 3.808. So 3.8 I'm just going to write down. And at 8 you get 4. So at 7 I have 3.8. And at 8 I have 4. Okay, so there's my line. So we said it's solid, so I'm going to connect them. Remember, always the same shape. And if you didn't have a graphing calculator, you would have probably plugged in 1 and you would have written the answer that the graphing calculator on here has. You probably would have written 2.7. Well, you just would have had to graph the point 1, 2.7. You know, and that's fine that you do it that way, just that you have to plug them all in individually. All right. Now the next thing is it says y is greater than, because now we have to do the inequality piece. So greater than. To be greater than, you shade above. Notice I don't shade to the left of where my line is, because there's nothing over here. There is no solution, so I'm going to just shade above. Okay. So that would be my solution for example 5. If you wanted to make sure your graph looked like, you can look at your graphing calculator and just go back, just hit graph, and it will show you the inequality. And you can compare. Do they look like they're graphed the same? Obviously, this one doesn't do the shading, but yeah, they do look like they're placed in the same place. Okay, so it looks like you did a good job. So you can always check your answer on the graphing calculator, which is nice. All right, one last example. Example 6. The speed v of a ball can be determined by the equation v is equal to the square root of 2k over m, where k is the kinetic energy in joules and m is the mass of the ball. Assume that the mass of the ball is 5 kilograms. Okay, so what we want to do is graph the function and then state the domain and the range. Well, we have to plug in the mass first. Okay, well, where was the mass? It was m. So we're going to graph that v is the square root of 2k over m. And we're just going to graph this one on our graphing calculator, but let's figure out the domain and the range. So remember, the domain comes from what's underneath your square root sign. I don't know why I rewrote m. Sorry, guys. What did we say m was? It was 5k. So we should 5 kilograms. So I'm going to write 5. All right. So let's find the domain. It's 2k over 5 is greater than or equal to 0. So to solve this, I would multiply both sides by 5. So 2k is greater than or equal to 0 times 5 is 0. If I divide by 2, k is greater than or equal to 0 divided by 2 is 0. So there's my domain. And my range is what's after my square root sign. Well, there's nothing. So it's not using y, it's using v. So v is greater than or equal to 0. So I know I'm going to be starting at the ordered pair 0, 0. Okay. And then it says to graph it. So I'm going to just sketch. Okay, in this case, my x is my k, and my y is my speed or velocity. Okay, and then I'm going to use my graphing calculator to do this one as well. Going to y equals, we're going to clear this one out, and I'm going to graph the square root of 2, and you have to use x on your calculator, 2x divided by 5. Okay, and I'm just going to go ahead and look at the table set. We want to start at 0 and go by 1, so we're there. Okay, and if I look at the table, I'm just going to look at what has fairly decent values. Well, it looks like to get to 10, you'd have 2. So we'd have 2, and then we have some values in between there. So let's just say 5 is 1.4142. So if I graph 5, it's 1.4142, so it'd be there. And if I graph 10, when I plugged in 10, it gave me out 2, and I had the order pair 0, 0. Okay, so there is the graph of it. Now B says the ball is traveling 6 meters per second. What's the ball's kinetic energy in joules? Okay, well, I need to decide where do I want to plug this in. 6 meters per second. Well, that's my speed, so that is V, so I would have 6 is equal to the square root of 2k over 5. So I'm trying to solve for what k is. Okay, well, at the beginning of this lesson, we talked about, well, what's the inverse of the square root? Well, to undo square root, you would square both sides. So 6 squared is 36. So 36 is equal to 2k over 5. To solve from here, I'd multiply by 5 on both sides. 5 times 36 is 180, is equal to 2k. And then I would go ahead and divide both sides by 2. So k is equal to 90, and this is in joules. Okay, so that is how I would solve that problem. Okay, so that will be the end of section 7.3 video. If you have any questions, like I said, please write them down. Let me know tomorrow in class. Otherwise, have a great day, and I'll see you later.